include Daggy. We'll call the tagged sum method. Pass it a constructor name and an object whose keys each represent a type within this sum type. So we'll go with alpha, give it a single property x, and bravo, and give it a single property x as well. Nothing too much to see there. We can take a look. There are some prototype methods already on there that come built in with Daggy. So we've got the constructor methods, alpha and bravo, that we've created above in the tagged sum. We've got it to string, and we've got cata method. Cata is catamorphism in this case. So that's actually the interesting piece of this, and that's what's the real power of using the tagged sum is. So let's just get into that right away. So we've got the sum type. We're going to make a new method called foo on its prototype. Foo is going to take a single argument that's a function, and it's going to return the result of calling the catamorphism of the current object. So when we instantiate this subtype, this will be on there. I'm not going to give anything there. We'll see how this goes. So we've got a sum. Let's give ourselves an instance of the sum type alpha. So give it the value x. Take a look at what that looks like. We've got an object with a single property x whose value is now 1. We can look at what x. We see that it's got the value 1. We can run a test to see that this is exactly what we already know it is. We can say, is this sum type? True. Is this specifically the alpha type? True. Is it the bravo type? False. So let's see what happens when we run this foo method. Just pass a function identity. That doesn't work. It says the constructors giving to cata didn't include alpha. So alpha is the type, the constructor that we're using within this sum type right now. What cata is expecting is arguments similar to the tagged sum constructors, that second argument to tagged sum. It needs an object whose keys represent all of the possible constructor types that this can represent. Now we get back our value because the function foo, the function we pass to foo isn't actually being run. What we're doing is just returning the value back as it was. You probably noticed though that now there is no x value because we're not returning another instance of alpha, we're just returning that value. So the idiomatic approach would be to instantiate a new instance of alpha here. Same thing for bravo. Just go ahead and get ahead of myself there and do it. Now we're back to where we started. We've got an object with a single property x whose value is 1. So let's run this function on our instances. We'll change this function to increment. Now the output is 2. So what happens when we change this to a bravo? Looks the same. Now what we can do here is have these two possibilities behave differently. So in this case I have, if I run the function, if I call foo with the function x plus 1 on an alpha constructor, I will return the initial value 1 plus 1, 2. If I run it on a bravo constructor, I will get the result of that function x plus 1, 2 plus x, which is 1, so it should be 3. So let's take a look, see how that goes. X is 3.